Excellent. You have arrived. Lecture 2 for Solutions Unit. I'm going to hit you up with your 20 words for the unit and their definitions. So your target is to be able to define these terms. Hopefully you can define them off your brain and not always using the matching. Okay, so check it out. 20 words, here we go. What is a solution? Well, there you go. You got a picture of them. Solutions are liquids that have stuff dissolved in them. Okay, it's a homogeneous mixture of solute and solvent. The solute is what gets dissolved. The solvent is what does the dissolving, which is our next two words. So check it out. Great graphic. Solute's the solid, solvent's the liquid, and when you mix the two, you get a reaction that produces a solution, a homogeneous solution at that. So here's your definition. It's the part of a solution that is being dissolved. It's the sugar, it's the salt, it's the chemical compound that dissolves in water. That's what it is. The solvent, same graphic, but we're going to talk about a different part of it. The solvent does the dissolving, and that is the water. It is the alcohol. It is the other liquid or sometimes gas that does the dissolving, but we only focus on water this unit, okay? So don't worry about the rest. Aqueous. Well, that bridges off of what we're talking about with water. Aqueous means dissolved in water, specifically, okay? So a solution where water is the solvent is aqueous. So if you ever see a chemical symbol, NaCl with parentheses AQ after it, it means that NaCl has been dissolved in water. Aqueous, water. Get it? Alloys. Alloys are actually solid solutions that we don't talk about too much this unit because they're mixers of metals together to make tailored type of metals that we can use more readily. It's a solution of two or more metals. Most of the metals you come into contact in life are actually alloys because the pure element metals are too reactive to be useful. So we mix other elements in with them to get them to be more useful for us. That's what a solution of two more metals is. It's called an alloy. All right. Next set, 5, solubility. It is a measure using reference table G typically of how much solute can dissolve in how much solvent. It's a measurability of solute to dissolve. How much will dissolve? That's your solubility. 5 grams per 100 milliliters, great, that's your solubility. There we go. Dissolve, I just used the word, now let's define it. Dissolve means to actually take the phase of the solvent, okay? So if your solvent is a liquid, the solid or the gas that you add to it will go into that phase and appear as if it was just a liquid, okay? So when molecules of a solute break apart from each other and take on the phase of the solvent is what dissolve means. It's quote unquote to disappear into the liquid, but it doesn't really disappear. It's still there. Dissociate, another word. This is what ionic compounds do. Only ionic compounds do this. When an ionic compound touches water, the positive and the negative ions can actually separate from each other, which is what allows the water to conduct electricity. But the simple definition of dissociate is when the atoms of a solute break apart, forming an electrolyte. Electrolyte, I just used the word. What does it mean? It means that the light will light up. No, it doesn't. Electrolyte means the liquid is able to conduct electricity. Electrolyte means able to conduct electricity as a liquid. So any solute that dissociates, ionic compounds, allowing the water to conduct electricity is considered an electrolyte. So salts dissociate and are electrolytes. Soluble, ability to dissolve, forming a solution. Anything that can dissolve and make a solution is soluble, some to greater extents than others. Insoluble, the opposite of soluble, not able to form a solution. So this would be a solid that falls to the bottom of a test tube or a beaker and doesn't dissolve at all. Forms a heterogeneous mixture, not a solution. No. Saturated. This is when you have dissolved the maximum amount of solute in your liquid, okay? You can't get any more in there. All the extra falls to the bottom. Saturated is full. It is a solution that's dissolved the maximum amount of solute at a given temperature. Saturated. Precipitate. Precipitate is when you have a reaction that produces an insoluble solid that will fall to the bottom of your test tube or beaker as a powder inside of the liquid. Doesn't dissolve, it falls to the bottom. So there's your precipitate. Could be a solid or look cloudy. That's how you know you've got a precipitate. Supersaturated. This is a solution that is supersaturated. We tricked it into having more solute than it's allowed to at a given temperature. And when you disturb the beaker there, it will crash out and make a, heterogeneous solution. So all the extra solute comes falling out of solution. It's dissolved more solute than it should at that given temperature. Simple. Concentration. It's a measurement of how much solute is in your solvent. And that's it. There's many ways to measure concentration, and we're going to cover a few of them. Okay. Concentrated versus dilute, however, is something that we all kind of already understand. The more concentrated, the darker in this particular scenario, and the more dilute, the lighter in this particular image. So the most concentrated ones are here on the left, and the least concentrated, the most dilute, are on the right. It's a relative comparison of solutions based upon the amounts of solute in the solvent. In order to do that, we should have measurement units for concentration, which leads us to molarity. Molarity, we're using moles from our moles and stoichiometry unit, and we're dividing them by the volume of the liquid that the sample is dissolved in. It tells you a number for molarity, moles per liter of solvent. Put a number on it, now you can compare concentrated versus dilute. Parts per million, another measurement of concentration for very dilute solutions. Okay, this is used by dividing your mass of solute by your mass of solution and multiplying by 1,000,000. So this is very useful for very diluted solutions, not concentrated, but diluted solutions. Percent mass and percent volume are basically the same calculation, except you're going to be doing the ratio of solute based upon the solvent. So you're going to take the part of that solution that's solute, divide by the mass of the solution, and multiply by 100, you get a percent. Or the part of the solution that is in volume, solute, versus volume of solution, divided times 100, and you got your percent. So percent mass and volume, very straightforward calculation. And the last word, boiling point elevation and freezing point depression. This is a phenomenon that happens when you add stuff to water. When you add stuff to water, you mess up the push me, pull you scenario of boiling. So the vapor pressure of the liquid always pushes up, and the atmospheric of the pressure of the earth always pushes down. When vapor pressure beats atmospheric pressure, you get boiling. But when you add stuff to the water, it interferes with that ability to produce vapor pressure. So you change the vapor pressure of the liquid, you're going to change the boiling point of the liquid and the freezing point too. It's why we add salt to the ice on our sidewalks. It gets in between the water molecules and prevents them from freezing together, so the temperature that they will freeze at drops down lower. The salt doesn't melt the ice. The salt prevents the ice from freezing. It doesn't heat it up to melt it. It prevents the molecules from getting close enough to actually freeze. And on the opposite end of things, when you put salt in the pasta water, it actually raises the boiling point of the pasta water a little bit. So your pasta, one, gets a little bit salty because that's good, and two, boils at a higher temperature so it cooks a little bit faster. And so there's your 20 words for our vocabulary on our solutions unit. Thanks for watching. Check you out in the next video when we get to our content. Oh, forgot to give you a definition. There it is. Boop. And that's all, folks. Clicky, clicky button, turn off the video.